In this video, I am going to explain what is a deterministic finite automata. This is called as DFA. So, deterministic automata is an automata which can be represented with a phi tuple. It is a machine which can be represented with a phi tuple. Machine M is equal to Q sigma delta Q naught F. This is a machine like finite automata. So where Q is a set of states defined in the finite automata, sigma is an alphabet, delta is a transition. That means delta maps Q cross sigma to Q, Q cross sigma to Q, and Q naught is the initial state and F is the final state. So now why it is a deterministic? What is the meaning of deterministic? The meaning of deterministic is upon taking one input symbol on one state, we are going to go exactly one state. Determinism means clarity without any deviation. There is no ambiguity. That means, let us suppose Q naught is your state. Upon taking some input symbol A on Q naught, you are going to Q1. That means there is only one transition on one input symbol from a given state. So on the state Q naught, on applying symbol A or input symbol A, we are going to exactly one state, not more than one state. That is called as determinism. That means one state, one input symbol, you are going to one next state. Suppose if I write on input symbol again A, if I go to another state, this is called as non-determinism. That means you are unable to say on taking input symbol A, are you going to Q1 or going to Q2? So that means same input symbol, you have different states. You are going to different states. This is non-determinism. Deterministic finite automata means on one state, by taking a single input, you are going to exactly one next state, not more than one next state. So this is what is called deterministic finite automata. So the definition is same. The definition of deterministic finite automata is same. It is a phi tuple machine in which Q is a set of states. Q is a set of states. Sigma is a finite input alphabet. Delta is a transition from Q cross sigma to Q. On taking one state from the Q, on taking one input symbol from alphabet, you are going to one of the states in Q. So this is same. So delta means it is a transition rule. How we are moving from one state to the another state upon taking one input symbol. And Q naught is the initial state. Always Q naught will be also from your set of states only. Next, F is a single final state or set of final state. Always F can also be from our set of finite states only. So this is the definition of deterministic finite automata. Now we have to construct the DFAs for various problems. So now we will see the step-by-step process of how to design a deterministic finite automata. There are some procedure. As per the procedure, we can simply design the DFAs for the given problem. Steps to design DFA. How to design a DFA? First of all, any DFA or any type of finite automata, first of all, you have to understand the problem. What is the problem they have given? If you understand the problem and the strings in the problem, the patterns of the strings in the problem, then we can happily design a DFA or any type of finite automata. So first of all, understand the language for which we have to design the DFA. The language means for what language we have to design the DFA. That means the problem. The problem you have to understand clearly. Understand the language for which we have to design the DFA. And after understanding the problem, first of all, write the language strings, the set of strings accepting by the language with the minimum string also. After understanding the long ways, first of all, you write the long ways strings. L is equal to, you write what are the long ways of strings. What are the strings accepting by the long ways, including the minimum string. Now, after writing the long ways of strings, then write design the diagram for accepting the minimum length string. First of all, you have to write the design, the DFA for accepting the minimum string. After writing the minimum string diagram, then you check the remaining possibilities for each input symbol. Obtain the possible transitions to be made for each state on each input symbol. So whatever the number of input symbols are there, for each and every input symbol, we have to check what will happen. Suppose my string has to start with 1. That means my string has to start with 1. So the minimum string is 1. That means it is starting with 1, 1, 0, 1, 1, 0, 1, 0, 0. So these are the strings accepting starting with 1. What is the minimum string? 1 is the minimum string. For that, I need to write the minimum diagram Q0. After that, you have to check what happens if 0 comes on Q0, or what happens 0 comes on Q1, or what happens when 1 comes on Q1. You have to check for all the possibilities. So in deterministic automata, we have to define all the input symbols and all the states. That means every state should be able to say what happens for all the inputs. Suppose if you take Q0, if your alphabet is 0, 1, you have to say what happens on 0 and what happens on 1. At the same time, here on Q1, you have to say what happens on 0 and what happens on 1. That means at each and every step, you have to see what happens on all the input symbols. So that's what here we have to see. We have to check for all the possibilities of all the input symbols on all the states. Now, after drawing the DFA, now you have to draw the transition table. Transition table for the given DFA. Then you have to check whether strings are accepting or rejecting. We have to test some few test cases with some strings for the acceptance of the string, for rejectance of the string. And finally, represent DFA with tuples. Tuples means your DF always will define the DFA with M is equal to Q, sigma, delta, Q0 and F. So finally, you have to define your DFA in this fashion. That is called as tuples fashion. So this is the designing aspect of a DFA. So what is step 1? First of all, you have to understand the long ways and you have to write the strings in that long ways with the minimum string. Second one is you draw the diagram for the minimum string. And third one is after drawing the minimum string, now you check the remaining possibilities for all the input symbols on all the states. And fourth one is draw the transition diagram, transition table. And fifth one is you take some few strings and whether you check whether they are accepting or rejecting. And finally, you represent the entire diagram in form of a definition of a DFA. That means in the tuples form. So these are the 6 basic steps of designing a DFA. Now we will see one example how you will follow these 6 steps. So first check. Here I have taken some example. Design a DFA that accepts all strings which starts with 1. That means we have to draw the DFA for accepting the strings where every string shall start with 1. What are the symbols in the string? 0 and 1. So 0 and 1 is the alphabet. So what is your first step? Understand the long ways. Understand the long ways which we have to design for the DFA. So what are the long ways? Every string shall start with 1. What is the minimum string here? 1 is the minimum string. Suppose if you write the language of strings L is equal to the minimum string is 1 and 1 0, 1 1, 1 0 0, 1 1 0. So these are different possibilities. First of all, what we have to do? We have to draw the diagram for the minimum string. We have to draw the diagram for the minimum string. What is the minimum string? Here 1 is the minimum string. Here our minimum string is 1. So now draw the transition diagram for the minimum length string. So let us suppose Q0 is the initial state, Q0 is the initial state, and let us suppose 1 is the input, 1 is the length. So now if you have 1, the string is accepted. That means the string starts with 1. So on Q0, on taking 1, we are going to Q1, and this Q1 is the accepted state. So now this is only the diagram accepting 1. But as per the definition of deterministic finite automata, we have to define all the inputs and all the states. Here on Q0 we have defined only 1 but not defined 0. On Q1 we have not defined 0 and 1. We have not defined what happens when 0 and 1 comes after 1. Now we have to check all the possibilities. In the third step, obtain all possible transitions to be made after each state on each input symbol. That means for 1 it is okay. What happens? 0 comes after 1. What happens if 1 comes after 1? What happens after 0, 1 comes after 1? These all possibilities we have to check. So now after 1, if any 0 or 1, we don't have any problem. Why? Because our string shall start with 1 only. Okay, it starts with 1. After 1, what is the case? Either 0 or 1 or 1 or 0. Any combination, we don't have any problem. So after 1, if any 0 or any 1 comes, I will be on the state Q1 only. That is the accepted state. Then what happens if the string starts with 0? If string starts with 0, it is not at all accepted. Why? Because the string shall start with 1. If it starts with 0, after 0, whatever the number of zeros and ones, there is no use. So that's why here, if 0 comes at the first start of the string, then I am deviating to the another state. So here I am taking Q2. On this, if after 0 comes, after the 0, any 1, any 0, there is no use. This is called as dead state. This is called as dead state or not accepted state. Non-acceptable state. Non-acceptable state. There is no use. If the string starts with 0, after 0, any number of zeros or any number of ones, there is no use. So if the string really starts with 1, after 1, whatever the number of zeros and ones, we don't care. Just will be on the self loop on Q1 only. That means final state only. So now the diagram is completed. That means we have discussed all the possibilities. That means what happens with 0 on Q0 we have discussed. What happens with 1 on Q0 we have discussed. That means for both the inputs we have discussed. Similarly on Q1 we have discussed what happens on Q0 and what happens on Q1. Similarly on Q2 we have discussed what is 0 and what is 1. That means we have to write all the input symbols and all the states. That is what deterministic finite automata. Every time we have to define all the input symbols and all the states. We have to say on what input symbol and where you are going. So now the diagram is completed. The deterministic finite automata is completed. Now we will see. Now we will see the transition table. After designing the transition diagram, transition table. This is transition table. Here we have 3 states: Q0, Q1 and Q2. Here this indicates Q0 is the initial state. Here this circle indicates Q1 is the final state. Q2 is some non-final state. Here the input is 0 and 1. What happens? 0 on Q0. If you see 0 on Q0, you are going to Q2. If you see 1 on Q0, you are going to Q1. Similarly, if you see 0 on Q1, you are going to Q1 only. If you see 1 on Q1, you are going to Q1 only. If you see 0 on Q2, you are going to Q2. If you see 1 on Q2, you are going to Q2 only. This is the transition table. Here, these are the current states. These are the current input symbols. These are the next states where you are going. These entries in the table are next states. Next states. So this is the fourth step in our process. The fifth step is we will take some strings and we'll check whether the string is accepting or not accepting. Here let us take a string w is equal to 1 0 0 1. Now we have to check whether the string is accepted or not. By looking at the string we can say, well, because it is starting with 1, so it is accepted. But mission doesn't have any eyes. Mission has to go through one by one, and it has to check with the help of the final state. So now delta of first of all, your initial state is Q0 and your string is W. Now you have to derive delta of Q0. What you are saying? 1 0 0 1. Now what happens? 1 on Q0, you are going to Q1. And what are the remaining states? Remaining symbols 0 0 1. Now what is the next input symbol? 0. What happens? 0 on Q1, you will be on the same state, Q1 only. Now what are the remaining two symbols? 0 and 1. What happens? 0 on Q1, again when you see a 0 on Q1, you will be on the same state, and you are left with another symbol. Now what happens if you apply 1 on Q1? You will be on the same state. And finally you will be on the Q1. So after consuming the entire string, finally you are at Q1. Q1 belongs to your final state. So your string is accepted. Let us take another example. Suppose W is equal to 0 0 1. We can say easily that your string is not started with 0 1, so that it is not accepted. But mission has to tell delta of Q0 comma W is equal to delta of Q0 comma 0 0 1. Here delta of, first of all, you apply the initial input 0 0 on Q0. Whenever you see a 0 on Q0, you are going to the state Q2, and 0 0 1 0 0 1. What is the next input symbol? 0. When you apply 0, when you see a 0 on Q2, you will be on the same state Q2 only. What is the last symbol? 1. When you apply 1 on Q2, you are going to Q2 only. You will be on the Q2 only. So is Q belongs to final state? No, Q does not belong to final state. So this string is not accepted by your DFA. Why it is not accepting? Because it is not starting with a 1. So like that, you have to check the conditions. By taking 2 or 3 strings, whether it is accepting or not accepting. And finally, you have to write the entire diagram in terms of your tuples. So finally, we are writing our entire diagram in our definition form. M is equal to Q sigma delta Q0 F. So what is our Q? In our diagram, Q is nothing but Q0, Q1, Q2. We have 3 states, Q0, Q1 and Q2. What is your sigma? We have 2 input symbols, 0 and 1. What is your delta? Here Q cross sigma to Q. That means you have to write the transitions. Delta of Q0 comma 0. Where you are going? You are going to Q2. Delta of Q0 comma 1. Where you are going? You are going to Q1. Delta of Q1 comma 0. Where you are going? On Q1 only. Delta of Q1 comma 1. Where you are going? Q1 only. Similarly, delta of Q2 comma 0, you are going to Q2 only. Delta of Q2 comma 1, you are going to Q2. So I have defined all the transition rules. And finally, what is your F? What is F is Q1. This is our final state. Our F is Q1. So like that, we have defined our diagram in terms of 5 tuples as per the definition of DFA. So anyway, Q is the initial state and F is the final state. Here the final state is Q1. So like this, we have to design the DFA. So this is the procedure of designing the DFA. So what is the procedure? So what is the procedure? 6-step procedure. So while designing the DFA, first of all, we have to understand clearly what is the long base and what are the patterns of strings in the long base with the minimum string. Second step is we have to draw the diagram for the minimum length string. Then the third step is you write all the minimum possibilities of all the inputs on the states. And fourth step is draw the transition table for the DFA. And fifth step is take 2 strings for test as test cases, one for accepting, one for rejecting. And finally, you have to represent the entire diagram in terms of our DFA definition 5 tuples. So this is the whole process of DFA. So now in this video, I have explained clearly what is a DFA with one example. In the next coming videos, I will take so many examples. In each video, I will explain one examples. Okay. Thank you for watching this video. Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.